Okay, let me start that over. So we're in our multi-step equations part. What we're doing for today is I can solve linear equations with multiple steps. We're going to be using distributive property. So what I want you guys to do is in your blue, you're going to underline, or if you're using a highlighter, you can highlight the distributive property word in blue. And then that we're also going to be combining like terms. That's going to be in orange. Before I actually solve. We're going to do those two things before any solving happens. So again, these two things, this distributive property and this combining like terms, that's what we've been doing all the time in our expressions unit. When we were in expressions, we were working on distributing by multiplying what's on the outside to what was on the inside. And then we were combining any like terms. So if we had several variables that were to the same power, same exact variables to the same power, we could combine their coefficients together. If we had several constants, which are values without any variables, we could combine those together. And that we knew to utilize our plus and minus signs as indicators of whether we're dealing with a positive or a negative. Okay, so that's what we're here. Step 1, step 2A, so we're replacing 2 with 2A, and then step 2B. These 3 steps are all what we did in our expressions unit. Distribute, combine like terms, and that's what you're seeing right here. You see it say distribute, and then same thing down here. 2A says to combine like terms. 2B says to combine like terms. And I just separated them out as we're going to combine like terms on the left side if needed, and then we're going to combine terms on the right side if needed. Then we get to step 3 and step 4, and that's when we had our solving equations portion. Step 3 and step 4. So Santonio, you were out. We replaced number 2 with 2A. We changed 3 to 2B. We changed 4 to 3. And we changed 5 to a 4. Okay? Okay, so let's go ahead and take a look at the very first example that's been provided for us. So it's a long one, a long example, and that's perfectly fine. I wanted to make sure that we got enough practice with every single type of process that there could possibly be. So when we're taking a look here, like I said before, we are first going to distribute. So I'm going to rewrite this expression right here. So 9x minus 4 parentheses 3x minus 6 close parentheses and then equals negative 3 plus 18. So when we say I want to distribute, we always are looking for what for distribution? How do we know that there is distributive property? What do you think, Jada? There's a couple special symbols up here. Yep, there you go. If it has parentheses, distributive property is going to have parentheses. So if you need to put that down as a reminder, that is what you are looking for. If you see parentheses, which we do, right? We see parentheses right here. And we have a value outside of that parentheses. We have that negative 4 outside of the parentheses. So that means we are taking that value of negative 4, which is right here, and we're going to multiply it to everything on the inside. So I'm multiplying it to this 3x. I'm also multiplying it to this negative 6. So using your blue, I want you to circle 3x. I want you to circle negative 6. And then also circle -4 with your arrows going to each. That way you can see again, you are distributing to each of those values. And distributive property means that we're going to multiply. So we're going to take -4 and we're going to multiply it by 3x, which is going to give us -12x. And then we're also going to take -4 and we're going to multiply it by -6. And that's going to give us a positive 24. Notice I had to put my plus sign. Remember all the way back to when we were talking about this in our expressions unit. Huh? Yeah. It's just 12x, -12x plus 24. Okay, so that's all we have from distributive property. Now, this 9x wasn't a part of it, but it still remains in the problem. So we just bring it straight down. 9x. Same thing here, our equal sign is still part of the problem. So we put equals. And in fact, this whole thing here is still a part of the problem. -3 plus 18. Okay, the only thing that changed is what I wrote in blue. That is the only part that actually changed, was our distributive property. Yes, dear? Eventually, we're going to get there. That's going to be part of the orange portion, which is combining like terms, right? Lucas was saying that -3 plus 18, can't we combine those? And yeah, we can. We can do that part because they are like terms. So that's where we're going to focus on 2a and 2b, the combining like terms step. I split them up because I wanted to focus on different sides, because I don't want you guys thinking that you can combine 24 with a -3 or 24 with the 18, because they're on different sides of that equal sign. Yes, dear? Yep, we are. We're getting to it. We're getting to it. Okay? So we are going to focus on just the left side first. So the left side, when we talk about sides, we're talking about the equal sign. Okay, we're talking about the equal sign. Okay, so what I mean by left side, I want everyone to take their sticky note, and we're going to cover up the equal sign and what was on the right side of it. This is the left side of our equation. Okay, that 9x minus 12x plus 24. We are only going to focus on this side of the equation at first. And we're looking for like terms. Malia? Like that? There you go. Okay, so we're just looking for the like terms that we can simplify with this expression. So like Lucas said, he said that 9x minus 12x can be simplified. So I'm going to go ahead and put a box. I'm using my orange. I'm going to put a box around the 9x minus 12x. I don't need to rewrite that because they're already side by side. If they were not side by side, then yeah, I would want to rewrite it. But what is 9x minus 12x going to give us?
3.
Negative.
Oh, negative.
Negative 3x. Okay, now plus 24 doesn't have anything that can be combined with it. So do we just ignore it?
No, you put it down.
You have to bring it down. We have to bring down plus and the 24. So now our left side is as simplified as it's going to get. Okay? Now we're going to do the same thing again. We're going to take that sticky note, and this time we're going to cover up the right or the left side of our equation. So here's our right side. This is the right side. So that's what we're going to focus on now, is the negative 3 plus the 18. Can we simplify that? Can we simplify that?
Yes.
Yes, they're both numbers. We can simplify that. So again, I'm going to put an orange box around it to show that they are like terms. They can be simplified. When I combine -3 and positive 18, we're going to get 15. Positive 15. Okay, so now we have both of our sides simplified. So I can rewrite them with the equal sign in between. I can write -3x plus 24. So I'm going to write that here. -3x plus 24. I can put my equal sign, and then I can put the right side, which was 15. And this should look familiar to you now. It's just a two-step equation that we do from here. So all we did in steps 1, 2a, and 2b were expressions. And now all we're going to do for step 3 and 4 is solve the equation. What's the first thing that we would need to do to that equation? Santonio?
We add 3.
Look up again. You forgot? Okay. Will? Very good, Will. We're going to put a box around that plus 24. Remember, we always identify the constant. That's what it says right here. We're going to identify our constant, and we're going to either add or subtract. We identify our constant, and we're going to either add or subtract. Are we going to add or subtract here?
Subtract.
Subtract. We're going to subtract 24, but remember, what we do to one side,
Here, do the other side.
got to do the other. Good. So we're going to subtract 24 away from 15 as well. Hey, I boxed it.
X it out.
Cross it.
Box it, cross it.
There you go. Okay, so we get -3x is now equal to, we're going to do 15 minus 24. 15 minus 24, Jordan? -9. Okay, so we get -3x is equal to -9. I'm going to rewrite that down here in my step 4 process. And step 4 says that we're always going to either multiply or divide. We're going to multiply or divide in order to finish solving. So taking a look here, do we need to multiply both sides or divide both sides? Corey?
Divide.
Divide. And then Jordan, what are we going to divide both sides by? -3. So we're going to divide by -3 on the left. We're going to divide by -3 on the right. I can box my -3 over -3, and I can cross. That means x is by itself. I don't want to box off x. X needs to stay. -9 divided by -3 equals +3. It can be very, very easy. Okay, so we're going to do a few of the problems together right now, and then I'm going to let you do a couple of them on your own. So, I think we'll do independent first, and then you can check with partners. Okay? So first thing I want to do, though, is I want to work on problem number 2. We're going to skip number 1. I want to work on problem number 2, and there's a reason for it. But let's take a look first. What's the first thing I should be checking to see if I could possibly do? Amara? Not yet. Yes, dear? Yep, distribute. Are we always going to have distributive property?
No.
No. We're looking to see if we do have it. So we're looking for those parentheses. Do we have parentheses? No. So we don't have distributive property. So now we go to 2a and 2b. So 2a says to check the left side. Thank you. So we're going to cover up the equal sign, and we're going to look at the left side. Can I simplify negative 12? No, can't simplify it. It's just going to get brought down. Along with my equals. All right, now I'm going to check the right side. Can I simplify anything here?
Yes.
Yeah. Okay, so we're going to raise hands now, okay? Who can tell me what can I simplify in this expression? Ethan. 5v and 2v. So let's go ahead and put boxes around positive 5v and positive 2v. When we simplify that, what is positive 5v plus positive 2v? 7v, right? Positive or negative?
Positive.
Positive. So what should I put in front of it?
Positive.
A positive sign. And the only reason I need to do that is because I still have this 2. I still have this 2 that needs to come down in the problem. I can't ignore it. It doesn't disappear. It's still there. So it gets brought down in the problem. So now I have this equation. Once we are in as simplified as we can get equation form, then we're going to go to what Amara said. And Mara, what did you say before? Rewrite it. If the variable's on the right, we're going to do a rewrite. Okay, if your variable's on the right, we need to do a rewrite. So when we rewrite it, does the order of this change? Am I going to now put 7v plus 2? No. You're going to leave it in that same order. You're still going to keep it as 2 plus 7v. It's just now on the left side instead of on the right. And it's going to be equal to negative 12. Okay, we should move to step 3. Do we have a constant that needs to be moved? Jordan? The 2. Okay, so we're going to put a box around the 2, but something's missing in front of it. Remember, I always like to have an operation or a sign in front of it. Lucas? A positive 2. So we're going to put that invisible plus sign there so that we now know that we must subtract. The only reason I say to do that is because sometimes it might say 2 minus 7v. But again, that minus sign doesn't belong to the 2, it belongs to the 7v, right? Okay, so we're going to subtract 2 from both sides. We boxed it. Now we cross it. Positive 7v. Positive 7v is what we're left with on the left. Negative 14 is what we now have on the right. Okay, we have 7v is equal to negative 14. Remember, step 4 says we're either going to multiply or divide. Which one do you think we need to do? We're going to multiply or divide? Will? Divide. And what are we going to divide both sides by? 7. Okay, we can box and cross the 7s. And we'll have v is equal to negative 2. Okay, so why don't we go ahead and once you've got that written down, I want you to flip it to the next page. And we're going to do problem 4 now. We're going to do number 4. I know. I told you I'm going to skip around because then whatever I don't work with you, you're going to work it on your own and we'll check through them. Yeah, we're going to go to problem number 4. Okay. Step 1, we always check to see if we can distribute. Can we distribute? No. There is no distributive property here. Okay, step 2, we use our little sticky note and we're going to cover up the sides. Okay? Covering up the sides, so I'm just looking at this expression. Can I simplify anything in this expression, Amara? Yeah, what can I do?
Positive 3 and negative
Yep, positive 3 and minus 3. Are you feeling okay, honey? You just tired? Okay.
3.
Yeah, it's Friday though. You guys get to have a whole weekend, okay? All right. Positive 3 minus 3. What does that give us?
0.
0, right? We're going to get 0 here, and it's okay. 0 is a number. Okay, so we need to bring the x down. What do I have to put between the x and the 0?
1.
Not a 1.
Oh.
I need an operation, okay? Plus sign. Okay, I'm going to put a plus sign. Okay, now we can move on over, cover up the next side. Can I simplify? Anything I can simplify with there? No, it's just a number, right? It's a single digit. So that's just going to come straight down. We have equals negative 6. Okay. Yeah. Mm-hmm. What did you do? What do you mean you tried 3 first? Tried 3 as what? Oh, so you did 3 plus 3 minus 3? So what you did is you did what we call a plug and chug. You did what we call as a plug and chug. You plugged in a number and chugged through the problem to see if it would work. And that's the thing though. I can give you everything in fraction form. Are you going to really want to plug and chug through that? No. What is going to work, whether you have whole numbers, negative numbers, fractions, decimals, is just solving. The process and the method that I'm showing you is going to work flawlessly every time. The plug and chug method, not going to work every time. Because you're going to come up against problems where it's decimals, fractions, maybe there's a combination of decimals and fractions and whole numbers. You're not going to want to sit here and try to test out every single thing you can think of. Okay? So you want to make sure you simplify and then solve. Noticing that these two are 0 pairs, this is an easy problem. You should be able to recognize that these were 0 pairs, and you're just left with really, technically, that x is equal to what? Negative 6. Because what is x plus 0? What is any number plus 0? It's always going to be that number. Okay, if I did 10 plus 0, I'm going to have 10. If I do negative 8 plus 0, it's going to be negative 8. So if I take x plus 0, it's just going to leave me with x. So we're left with x is equal to negative 6. I don't have any coefficient that I need to divide by because my coefficient is already a positive 1. If it was a negative 1, I would still need to continue solving. But this was a positive 1. So this is a more simplistic problem. But you wouldn't be doing the same method here, would you? Yeah. You would want to make sure, or for here, you would want to make sure that you're using the method that I'm teaching you, which is to follow those steps, okay, and work it out. You are not the first one to do that and say, well, can't I just test this out? And I looked at it and I knew I could just plug this in and it would work. You don't want to do that. I have kids every year who say, well, this is what I did for this problem and it worked for this one, but it doesn't always work for every problem.
Yeah, I was going to say, it worked one time before,
Yeah, you have to stop. So that's why I say everybody wants to come up with a shortcut that will work for one problem, but shortcuts are not good shortcuts unless they work for everything. And if there's a shortcut that will work for everything, I guarantee you we're going to teach it to you. Right? Because we want you to be able to do the best that you can. Okay, let's take a look at number, we'll do number 5. We're going to take a look at number 5. Okay, so we have 6 equals negative 3, parentheses, x plus 2. First question that we ask ourselves,
Yes.
can we
Distribute.
distribute? Can we just distribute? Yeah, right? We have parentheses here. I'm going to highlight my parentheses. I can distribute. So I am taking negative 3, and I'm going to multiply it by x. So I'm going to write negative 3 times x. I can also take negative 3, and I can multiply it by positive 2. Okay, I want to make sure you guys know to circle each of those terms so that you include the sign with it. The signs are just as important. So negative 3 times positive 2. All right, what do we get when we multiply negative 3 times x? Amara? Negative 3x. Good. Good fix. Okay, what do we get when we multiply negative 3 times 2? Will? Negative 6. So we put negative and 6, and now it looks like negative 3x minus 6. Right? When we put them together, that becomes our new expression. Okay, I'm going to bring down the rest of the problem. I made sure to do my distributive property. All right, step 2, we're going to focus on the different sides. So take our sticky note. Everybody's got their sticky note. Let's cover up the right side. Can we simplify the 6?
No.
No. That 6 is as simplified as it's going to get. Can we simplify? We're going to cover up the left side. Can we simplify negative 3x minus 6? No. That's as simplified as it's going to get. So there was no combining like terms here. Okay, so we are as simplified as we can get. Now we get to solve. What should I do? Rewrite. Good. We're going to rewrite. If the variable's on the right, we do a rewrite. Okay. Negative 3x minus 6 is equal to 6. Leah, what should we do first? Right here. What should we do? Think through. We did our distributive property, so we did step 1. We looked at step 2a and 2b. We didn't have anything to do there, so now we're moving on to step 3. Look back at your notes. What did step 3 say to do? Okay, so let's identify the constant. Negative 6. We have a minus 6. Minus 6 is our constant. We identify and we use either addition or subtraction to move it. Are we going to add it or subtract it? Add it. We're going to add 6 to both sides. Then we boxed it and crossed it. Good job. Okay, so when we do that, we're going to get negative 3x is now equal to what? What's 6 plus 6, Jada? 12. Oh, this is a 6 and this is a 1? Yeah, but since that's an opposite one, though, right? Okay. Here, negative 3x equals 12. Lucas? Uh-huh.
Why didn't we not rewrite it at the beginning?
I always say to just wait to rewrite when it's simplified to a 2-step equation, because if you have a whole lot of things going on and there needs to be a rewrite, do you really want to make sure that you rewrote that correctly?
Yes.
I mean, you don't want to sit there and be like, oh, okay, let me make sure I'm transferring everything fine because I've got all these different operations and all these different terms. It's a lot easier to rewrite something this short than it is to rewrite something really long, right? So simplify before the rewrite. Rewrite is a part of the solving the equations process. Okay, once we're here, we're at negative 3x is equal to 12. And that's a very good question, by the way. Okay, negative 3x is equal to 12. We're at the last step. Last step is to multiply or divide. Are we going to multiply or divide? Divide. We're going to divide both sides here by negative 3. Don't forget the sign. We're going to divide both sides by negative 3. We can cross off the negative 3's, and x is going to equal negative 4. All right, so what I want you guys to do, you're going to go back to the first page. Problem number 1 we didn't do. I want you to do it. Then you're going to turn back to this page, and you're going to complete the remainder of the problems on this page that we did not get to. Okay, so we have 4n minus 2n is equal to 4. We do not have any distributive property, so there's no step 1. We do have combining like terms. We happen to be able to combine 4n minus 2n. When we do that, that gives us 2n. So we have 2n is equal to 4. 2n is equal to 4. We don't have a step 3 because we don't have a constant. There is nothing that we could add or subtract onto both sides. So we skip step 3. We go to step 4. We can multiply or divide, right? We can divide both sides in this situation by 2. The 2's will then get canceled out, and we'll have n is equal to positive 2. So number 1, you should have gotten n is equal to 2. Lucas and Amara. Hoods off, please. Amara? Thank you, dear. All right, let's take a look at problem number 3. For problem number 3, again, step 1, distributive property. Do we have any parentheses?
No.
No, we do not. So there is no distributive property here. Step 2, combining like terms. Nothing we can combine on the left side, but we do have stuff we can combine on the right. I have x, and I have negative 5x. So I can write x minus 5x, which will give me negative 4x. Everything else comes down, so we have 3 equals, and then this plus 3 is going to go in the back right here. We have 3 equals negative 4x plus 3. Okay, now we're going to do a rewrite. We're going to do a rewrite. We have negative 4x plus 3 is equal to 3. Here's our constant. We're going to get rid of the plus 3 by subtracting 3. The 3's will cancel out. We are left with negative 4x is now equal to 0. And a lot of you are coming up and going, is this okay? Did I do this all right? Yeah, 0 is a number. When we divide both sides by negative 4, you're going to get that x is equal to 0, and that is okay. 0 is a value. It is a number. Okay, let's take a look at problem number 6. First thing to ask, do we have distributive property? Can we distribute? Yeah. We have a negative 3 that can be distributed to this 4x and to this minus 8. So we're going to do negative 3 times 4x, and that's going to give us negative 12x. We can do negative 3 times negative 8. And that's going to give us a positive 24. And the whole thing is set equal to negative 36. All right, if I cover up, can I simplify anything here? Negative 12x plus 24? No. Can I simplify anything here?
No.
No, that's just going to say negative 36. I can't simplify, so now I go and I solve. Do we have a constant?
Yes.
Yeah, what's our constant? Positive 24. So let's go ahead and get rid of it by subtracting 24. We're going to subtract 24 from both sides. We boxed it and crossed it. We're left with negative 12x is now equal to negative 60. Okay, can we multiply or divide? Divide. We can divide both sides here by negative 12. Okay, the negative 12s are going to get boxed and crossed. X is going to wind up equaling a positive 5. Okay, problem number 7. Do we have distributive property?
Yes.
Yep. We can distribute this 1/4 times 5x and times the negative 8. So 1/4 times 5x is going to give us 5 over 4x. It is perfectly fine to have an improper fraction. We're also going to do 1/4 times negative 8, and that's going to give us a negative 2. So we now have 8 is equal to 5/4 x minus 2. I don't like that. I want to rewrite. So it's in the correct form. I'm going to put 5 over 4 x minus 2 is equal to 8. Do I have a constant?
Yes.
Yeah, right? Minus 2 is my constant. So I'm going to what?
Plus 2.
Plus 2. Thank you, Corey. We're going to add 2 to both sides. Boxed it and crossed it. We're going to be left with 5 over 4x is now equal to 10. All right. Are we going to multiply or divide? Divide. Even though it's a fraction, the fraction is in front. The fraction is in front, so we're going to go ahead and divide. We're going to divide both sides by 5 over 4. And we'll get x is equal to 8. Okay, we're going to stop here. We'll do problem 8 on Monday. No homework. No homework. Have a good weekend.